Our next presenter is Danielle Bartholet. She is a third-year PhD student in chemical engineering, and the title of her presentation is Designer Fuels.
Imagine you're at the gas station, filling up your tank. You step out of your car, swipe your card, and watch the numbers ticking by on the pump. Your car, your credit card, and the pump were all designed very intentionally to carry out specific purposes. But what about the fuel that's flowing into your gas tank? Have you ever thought about where it comes from or how we came to be so dependent on it? Basically, petroleum is like dinosaur juice. It's the carbon-rich remains of biomass that has been cooked inside the earth for millions of years. We didn't design it. We simply discovered it, oozing from the ground, and realized we could burn it for energy. In the past, all kinds of industrially valuable chemicals have been discovered in a similar way. We observe the properties of a substance, then determine potential uses for it, a bit like a hammer looking for a nail. But if we so intentionally design everything else in our lives, then why has the discovery and development of chemicals, from pharmaceuticals to fuels, taken such a different path? My PhD project focuses on the rational design and synthesis of fuel molecules. This is a shockingly new concept, but the idea is simple. First, we recognize the challenges we want to address. Then, we use our knowledge of chemistry, along with the power of computational tools, to tailor-make a fuel with the properties we need. Let's think about that gasoline or diesel you're pumping into your car right now. They've done some pretty amazing things for mankind, but it's safe to say that they're far from perfect. They have undoubtedly contributed to the climate crisis we face today, as well as millions of cases of respiratory health issues from harmful emissions of soot. My project aims to design and produce a fuel that doesn't just keep us moving forward, but that also protects human health and the future of our planet. With an understanding of the way chemical structures affect a molecule's properties and combustion chemistry, I proposed a group of 60 novel candidate molecules. I then used a variety of predictive models to estimate the properties of these molecules, as well as potential pathways for their production. After examining these 60 candidates, I've identified 3 molecules that, 1, can be produced sustainably from biomass, rather than non-renewable fossil fuels. 2, burn cleanly and efficiently, dramatically reducing harmful emissions. And 3, that are compatible with the engines that we already rely on today. So as you stand there pumping your gas, you can probably imagine, our transportation system is here to stay for a while. But there is something we can do today. We can ditch the dinosaur juice for designer fuels.